In this problem, I am given a point, and I'm told it lies on the terminal side of an angle which is in standard position. So I'm going to start, and I generally like to start with drawing a picture. So I'm going to draw an XY axis. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And it says I have the point -4, -2. So here's -4, here's -2, and it's saying that lies on the terminal side of angle theta, which is in standard position. So it's in standard position. My initial side is always the x-axis going positive, and then my terminal side is going to go through this point by definition. So here is my angle theta. That whole long thing right there. And if you remember then when we're finding trig functions, this is the reference angle, and I'm going to go from my point, and I'm going to draw my triangle by going up to the x-axis, always to the x-axis, never to the y-axis, never diagonally, always either straight up or straight down to the x-axis. So I have a triangle here, but it is not on the unit circle, because the unit circle by definition has a radius of 1. Well, I already know that I have one side here which is -4, and another side here which is -2. And I can see that this radius, or this ray here that's making my angle, is always going to be the hypotenuse of the triangle. And the hypotenuse is the largest side of a triangle. So there's no way it can be 1, because 1 is smaller than 2 and 4. So that's not going to work at all. In order to calculate my trig values, I'm going to have to use Sohcahtoa. And I'm going to have to find out how large the hypotenuse is. Well, I can find out how long the hypotenuse is, because I need that h for the Sohcahtoa. I'm just going to go -2 squared plus -4 squared is equal to my hypotenuse squared. Now remember, it's -2 squared, so this is going to be a +4. And it's -4 squared, that's going to be a +16. And that's going to be equal to c squared. So this is going to be 20 is equal to c squared. And what I'm going to do is I'm going to take the square root of both sides, and I'm going to get c is equal to the square root of 20. Now, in order to complete this problem properly, I really need to see if I can simplify this. So c is equal to the square root, and I can see that there are perfect squares in here. I have the perfect square of 4 times 5, so really it's equal to 2 times the square root of 5. That's going to be my hypotenuse. So back up here to my picture. My hypotenuse is 2 square root of 5. So now I can start calculating my 6-pack values. Here's my reference angle. So I want the sine. I pretend it's a little eyeball, and it's looking at the side opposite. So sine of this angle theta is going to be -2 divided by 2 radical 5. Sine is opposite divided by hypotenuse. So there's the side opposite, there's the hypotenuse. Well, I see that I have a common factor on the top and the bottom of 2. So this is really the same as -1 over radical 5. So my sine value is equal to -1 over radical 5. Well, what about my cosine value? Well, cosine is the adjacent side. So cosine theta is going to equal -4 over my hypotenuse, 2 radical 5. And again, I can simplify a little bit, and this becomes -2 over radical 5. So cosine is negative 2 over radical 5. Let's see if I can find the tangent. Well, tangent is sine over cosine. So tangent would be tangent theta would be negative 1 over radical 5 divided by negative 2 over radical 5. And I can see since I have the same denominators, those are going to go away. So I'm going to wind up with negative 1 over negative 2. Negative divided by negative is a positive. That is simply 2. So tangent up to 2. What am I talking about? Negative 1 over negative 2. It's 1/2. Not, see, what are you going to say? Positive 1/2. Positive 1/2. And now I can find my reciprocals pretty easily just by flipping these over. So my cosecant is going to be negative radical 5. Well, you could say negative radical 5 over 1, but that's unnecessary. My secant is going to be negative radical 5 over 2. And my cotangent is going to be 2. So the key thing here is to realize I can only use the unit circle values if I have a unit circle. If I have something that are angles in 30, 60, 90s, and as I hypotenuse of 1. But in this particular case, I had to use my Pythagorean theorem in order to figure out what are all 3 sides of the triangle. So then I can go back and use my Sohcahtoa to actually find the specific trigonometric values.